Hello, hope everybody's doing well. Today we're going to be doing our video for 1.2 line segments. Trying to keep the video under 30 minutes. So 1.2 line segments, get into it. We got a coordinate. Again, at any point in time, if I'm going through this, if I'm going too fast, pause that video. There may be some times I'm going to tell you to pause it and try something yourself. But we got our coordinate here is the first term, the number that corresponds to the point. So we look on a coordinate plane, that's when we have an x and a y coordinate, x comma y coordinate. On a number line, there's only one number that is the coordinate. And even though we've got -2, -1, 0, 1, and 2 marked on here, there's an infinite number of coordinates that are in between all of these points and in both directions. As we see, there's arrows pointing all the way left forever and right forever. The distance, okay, that's the distance between 2 points is the absolute value of the difference of their coordinates. Just to talk about a couple things in this definition. So absolute value, right? So the absolute value is when we have these two vertical lines, and the absolute value is actually the distance that number is from 0. So if I said the absolute value of -3, that would be 3. Okay, distance is always a positive. When we're talking about distance in geometry, it's always a positive value, right? Now the absolute value of 3 is also equal to 3 because both -3 and 3 are a distance of 3 from 0, okay? So that's what absolute value is. Difference, that's talking about subtracting things, right? So we can find the distance between two coordinates by subtracting one coordinate from the other and then taking the absolute value. All right, so we've got 4 points on here, A, B, C, and D. All right, A is at -6, B is at -2, C is at 0, D is at 5. All right, we've got these 4 values down here, AB, BD, DA, and AC. And when we write 2 points next to each other without any symbol above it or next to it, all right, we're talking about the distance between those points. So when we write down AB, that means the distance between A and B. All right, so that's why we can say AB equals, because we're talking about a value, a distance there. All right, so now a lot of times you can just count the distance, okay, especially if you've got tick marks that are, and you're given whole number coordinates. So in this case, I see that AB is, let's see, 1, 2, 3, 4. The distance between the two is 4, so it would equal 4, right? Now let's say we've got bigger numbers, or we don't want to have to count them like that, right? Or we don't have tick marks to try and figure them out. What we can do is we can actually use what we talked about on the previous slide, the absolute value of the difference. So for BD, okay, I'm going to put an absolute value symbol here, and that's the absolute value of B is -2 minus the coordinate of D, which is 5. Let's see, -2 minus 5 is -7. And the absolute value of -7 is 7. So BD would equal 7. All right? And we could do that by hand to double check, but it does equal 7. Okay? If you want to pause the video right now and give DA and AC a try on your own, that'd be a good idea. I'll pause for a couple seconds here if you want to pause the video yourself. But it looks like the lengths for DA is going to be 11, and the length of AC is 6. All right, segment addition. So if we have segments, because when we're talking about distance, like we did on that last slide, like AD, okay, it was the distance between AD, but that also represents a segment length, okay? That's the segment AD, and the length of it equaled what we found on the previous slide. In this case, what we're talking about is segment additions. So if A, B, and C are collinear, meaning they're on the same line, and B is between A and C, then AB plus BC equals AC. It basically means if we've got let's say a line, and we've got 3 points on the line where one point is in between the other two, if we were to divide it into the two small segments that make up the biggest segment, we could add those two smaller ones together to equal the big segment length. So in this case, we've got 3 points, point D, E, and F. We see that the length of DE is 3, the length of EF is 6, and the length of DF, using segment addition, 3 plus 6 is 9. Okay? So this is a pretty straightforward example using segment addition. Okay, here's one where we're given segment DE is 12, and the big segment DF is 17, and now we're missing that segment length EF. So what we can do is we can take our total segment, 17, and subtract the 12 off, leaving us with EF. Okay, so 12 minus 17 is 5, gives us a segment length of 5 for EF. Okay, now these segment lengths are all numeric, okay, pretty straightforward. We can also use variables for segment lengths, okay, or variable expressions. So in this case, we're given AB is x plus 1, BC is 3x, and the full length, AC, equals 9. Now what we can do is, when we have these variable expressions, we can set up an equation, okay, because now we're going to have missing values within that equation that we can solve for. So I'm going to go ahead and set this up using segment addition. AB is x plus 1, BC is 3x, so we're going to do x plus 1 plus 3x, equals the total segment length of 9. Now we're just solving an algebraic equation. So combine my like terms, x and 3x is 4x, plus 1 equals 9. Subtract 1 from both sides. 4x equals 8. And then divide both sides by 4. We get x equals 2. Now, we were asked to find the value of x, which we did, x equals 2, and the measure of BC. So I've got to go over here to my BC expression and plug in 2 for x. So that's 3 times 2 equals 6, right? Now, if I wanted to double check, I could plug my 2 in here for AB and get that length, right, which is 3, and 3 plus 6 does equal 9. Right? But they were specifically asking for the value of x and BC, the measure of BC. So 2 for x and 6 for the length of BC. Okay. Okay, this one's a little bit harder. And we're also not given a picture, right? Now, what I recommend you do, if you're not given a picture but given a description of the picture, is to draw it. So in this case, it says L is between M and P. So I'm going to go ahead and draw a segment and put a point in the middle. Now it says L is between, so L's in the middle. M and P are the endpoints of our big segment. All right. Now they want us to find the measure of ML and the measure of MP. Okay. Well, in order to do that, we're going to need to have to solve for x. So we got to set up an equation. Let's write down what we know. ML is 2x plus 5. LP is 3x minus 4. And MP, the full segment length, is 7x minus 3. All right. Let's go ahead and set up an equation using segment addition. 2x plus 5 plus 3x minus 4 equals 7x minus 3. Then go ahead and combine like terms. 2x plus 3x is 5x. 5 minus 4 is a positive 1. Now I usually like to keep my value in front of my variable positive, so I'm going to take the 5x and subtract that from both sides. That way when I do 7x minus 5x, I'm left with a 2x, positive 2x. Going to add 3 to both sides to get rid of that minus 3 on the right. That'll leave 2x on the right, and 1 plus 3 is 4. And lastly, divide both sides by 2, leaving x by itself on the right, and 4 divided by 2 is 2. So 2 equals x, or x equals 2. Now we didn't need to solve for x as far as what we're looking to give as an answer to this problem. We have to figure out what ml and mp are. So I have to plug 2 in for x. So for ml, 2 times 2 is 4, and 4 plus 5 is 9. There's one of my answers. Okay. Now, I need to be careful though, because I need to make sure that I'm solving for the right thing. Don't just go to the very next thing and be like, all right, plug 2 in here and get my next answer. No, we're looking for MP. So we got to plug 2 in here on the bottom one. 7 times 2 is 14, and 14 minus 3 is 11. Okay. Now I look at this and I'm like, I don't know if that's right, because it looks like LP might be more than 2, and I know 9 plus 2 needs to equal 11. Let's just plug in 2 here for LP just to make sure. 3 times 2 is 6. 6 minus 4 does equal 2. So that helps check out that we did the problem correctly. Okay. All right, finding the coordinate. Sometimes you're going to be given a coordinate and the distance between points, and you're going to use that to find the coordinate of one of the other endpoints. So in this case, we know that B is at -1. That's the coordinate of B. And we want to figure out what the coordinate of C is, knowing that this distance is 10. Right? Now what you can do, nice thing with distance, if you're on a number line and you move to the right, you can add the distance onto that coordinate to get your new one. So -1 plus 10 is going to be -9. Okay? So we get -9. If we were looking for a coordinate that's further to the left on a number line, all right? Well, when you go to the left, you would subtract the distance. Okay? Moving right, you add the distance. Moving left, you subtract. All right. So we've been working on a number line, which is just numbers on, okay, one number. Now we're looking at 2 number lines, an x and a y, which then all the coordinates, if you look at all the x, y coordinates, gives you a plane, a flat surface that goes in all directions. Now in this coordinate plane, we have 2 coordinates. So if I want to find the distance between them, we have to know a way to do it. Okay? Now, I have up here, and you may want to write this down. This is the distance formula. The distance formula works great. Okay? And you can use all of your coordinates. Okay? You're going to be given 2 xy coordinates, and you want to find the distance between them. You can plug them in to this distance formula. All right? Personally, I don't like to use the distance formula. There is another way. Okay? Now, if the numbers are really big or they're decimals, things like that, you've got to use the distance formula. Right? But almost everything we do here in geometry is going to be something that is going to be a little bit smaller numbers, things that are more manageable. And what I'm going to do is I'm going to take this line that we have, this segment that we have drawn in the coordinate plane, I'm going to make that the hypotenuse of a right triangle. right? And if you remember, there's a way we can find lengths of missing sides in a right triangle, right? And if I put these letters up here, it may help you remember. A squared plus B squared equals C squared. It's the Pythagorean theorem, right? And really the distance formula is just the Pythagorean theorem solved for C, okay? And we have D written up there as distance, but really it's the Pythagorean theorem solving for C. It's the exact same thing. But what I'm gonna do is I'm just gonna find the lengths of A and B and plug them in and then solve for C. So now you do need to be careful because if you look at the scale, okay, every 2 blocks represents 1 unit on our scale here. So I can't count the blocks. I need to count the number of units. So let's see, from this right angle up to the 4, 3 coordinate, 1, 2, it's got 2 units. So my A value equals 2. My B value is 1, 2, 3, 4, 5, 6. Right? So I'm going to plug those in. We got A is 2. So 2 squared plus 6 squared equals C squared. We don't know what the length of C is. That's what we're solving for. So let's do that. 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. The way I solve for C, okay, in this case, I got to take the square root of both sides. I'm going to rewrite C on the left side. C equals the square root of 40. Now, we are going to spend some time later on this semester simplifying radicals, so putting these in simplest terms, so they'd still be exact answers, but in lower terms. But for now, I'm going to let you guys leave it in this expanded form of radical 40, or if you want to, you can estimate your answer by taking the square root of 40 and rounding to 2 decimal places, right? And we get about 6.32 for the length of the segment given, okay? Again, if you want to use the distance formula, which is what we have along the top here, by all means, go for it, right? You are allowed to do that. You will get the exact same answer. It is the Pythagorean theorem, just in a little bit different form. Okay? All right, we're going to move on to midpoints. Midpoints. So midpoints are still part of segments, okay? We're just talking about a specific part of the segment. M is the midpoint of segment AB if and only if AM equals MB. And here's a way to notate that two segments are the same length. Okay, we can put a little hash mark on each of them. Okay, if I put a single hash mark on each, that's telling me that the distance between A and M is the same as the distance between B and M. All right? So we see that if and only if statement. That means that if you have 2 congruent segments, AM and BM segments are equal to one another in length, then you have the point that's in the middle would be the midpoint. Okay, M is the midpoint of AB if and only if AM equals MB. All right, so if I wanted to look at just 2 of these points, all right, let's say A and B. I want to find the midpoint between A and B, all right? Well, I need the 2 segments AM to equal BM. I need those segments to be equal. Well, a good way to find the midpoint between 2 coordinates, all right? Think about this. We're talking about something that's in the middle. If we're given 2 values and we want to know what the middle of those 2 values is, in between those 2 values, what do we do? Well, a lot of times we average the values out. So that's one way we could do this. We could find the average of the 2 coordinates. So I can do -4 plus 10 and then divide them by 2. All right? Well, -4 plus 10 is 6, and 6 divided by 2 is 3. Now, just to double check, I see that between 3 and 10, I have a distance of 7, and between -4 and 3, I also have a distance of 7. So it does work out. My two smaller segments are equal. All right, here we can find the midpoint, okay? We can find the midpoint on a coordinate plane. Now, we're not going to use the Pythagorean theorem here because we're not trying to find the length of this, all right? We want to find the coordinate of the midpoint, okay? So here's what we're going to do. We need to figure out what the coordinates are first. So this top right coordinate, 1, 2, 3, 1, 2, 3, 4. That's at 3, 4. The bottom left one, 1, 2, 3, 4, 5, 1, 2. So it's at -5, -2. Now, just like we found the average, okay, we found the average of the two coordinates on a number line, we can do the same thing here, but we got to find two averages, right? If I want to find my midpoint, because I'm not exactly sure where it's at, I can probably look at it and figure out, no, it's about right here. But if I want to find that exact midpoint, what I'm going to do is I'm going to take the average of my x values. So that's going to be -5 plus 3 divided by 2. And I'm going to find the average of my y values, -2 plus 4 divided by 2. All right? Now let's see, what are these? -5 plus 3 is -2, and -2 divided by 2 is -1. -2 plus 4 is 2. 2 divided by 2 is 1. So let's see what that is. -1, 1. There's my midpoint. Okay, at -1, 1. So midpoints, think of midpoints as averages. All right, you can find the midpoint on a number line by taking the average of the coordinates. You can find the midpoint of a segment on a coordinate plane by finding the average of your x's and the average of your y's. Okay. Midpoint formula, this is exactly what we just talked about. Okay, it's where we're taking our x's divided by 2 and our y's divided by 2. So if you needed a more standard looking definition and formula, it's right here. Feel free to write that down if you need to. All right, this one is a little bit different because now, okay, I skipped over this last example because it's exactly what we just did. We just found, you're finding the midpoint, they just gave us the endpoint. So we'd still just need to find the average of our x's and the average of our y's in order to get our midpoint between the two, okay? But this example here, this one's a little bit different, okay? This one says if the midpoint is at 3, 4, okay, M is the midpoint of a segment with endpoints at A and B. Find the coordinates of B if the coordinates of A are 5, 11. Here's what I'm going to have you do. I'm going to have you just draw a little sketch of what this will look like, okay? Now again, it doesn't have to be exact, but it's just going to help us in solving this problem. Now I usually just draw a segment from left to right. And I know this isn't, like I said, it's not exact, but I know my midpoint is at 3, 4, and I have one endpoint at A and the other endpoint at B. And my endpoint at A says the coordinates of A are 5, 11. I know these aren't even close to completely accurate, but you're going to see why this is going to help us. And our B, we don't know what B is. We're trying to figure out what our values of B are going to be. All right, I'm going to use this little diagram I made to help me find what my B coordinate is. All right, so look at your x values in A and M. Now to go from 5 to 3, I'm going to move 2 units negatively. Well, if this is the midpoint, I know I'm 2 away, I need to move another 2 units to get to my B x value. But because I moved negatively, I've got to move negatively again. So 3 minus 2 is 1. I'm going to do the same thing with my y values. From 11 to 4, I'm going down 7. So I need to go down another 7. 4 minus 7 is negative 3. So my b coordinate will be 1, negative 3. Okay. Now, we could do this by taking our midpoint formula, and we could set up values where we had missing values. Okay. And I'll set that up. I'll do one of those with you. I'll do the x value with you on that. Because I know that if I were to take my x value in A, let's do 5 plus x. I'll make that x here is my missing b value. 5 plus x divided by 2 is going to equal the midpoint x, which is 3. Right? Then I could use this to solve for x, which is that x value in our midpoint, or sorry, in the other endpoint. So I'm going to multiply both sides by 2, and I'll have 5 plus x equals 6. Then I subtract 5 from both sides. I get x equals 1. And that's that same value of 1 that we found using this step method right here. Okay? So again, you've got a couple different ways to solve for these other endpoint coordinates. It's up to you which one you would like to use. But again, I like to show you at least a couple different ways to do each of these problems so that you can figure it out best on your own. All right. We also do have midpoint problems that involve variables. Okay. I believe this is our last slide. So here we are told m is the midpoint of segment xy. Find xy if xm is 7x minus 13. xm is 7x minus 13. Okay, I like to write in these values. And my is 2x plus 12. Right? Now, you may be wondering, well, how am I going to find a length if I'm not given any length of the segments? Well, we know a property about midpoints is that we are given, or that we have two congruent segment lengths. So we know that this 2x plus 12 and 7x minus 13 are equal to one another. All right? So we can set them equal. 2x plus 12 equals 7x minus 13. And we can then solve for x. I'm going to subtract 2x from both sides. I'm going to add 13 to both sides. And then we'll divide both sides by 5. We get x equals 5. Now, again, finding x isn't what we're ultimately trying to do. We are trying to figure out the length of xy, right? Well, none of these are xy. One's xm and one's my. But I know that they're equal to one another, so if I can find one of the length and double it, it should give me the full xy length, okay? So I'm going to go ahead and plug it in. I'm going to put it in this one. This one looks like it's easiest. 2 times 5 is 10, and 10 plus 12 is 22. And if both of these segment lengths are 22, when I add them together, I get a length of 44. There we go. All right, that takes care of 1.2. Keep your eyes open for 1.3 and the assignments that go along with 1.2 and 1.3. And keep working hard on this. Good job. See everybody soon.